Okay, here's your last lesson in here. You are using congruent triangles to prove a couple of things. Well, first, to prove that the points on a perpendicular bisector are equidistant to the endpoints. You're going to show that angle doesn't work and side angle doesn't work, and then you're going to use the theorems to determine triangle congruency. So we've known for a long time that points that are on the perpendicular bisector are equidistant. It makes a lot of sense. You're supposed to construct the perpendicular bisector using the technique that we've described earlier. Place point C on the bisector somewhere above, and point D somewhere below, and then point E that is on the perpendicular bisector, or on the segment AB. And then you're going to form a triangle AEC, BEC, and you're going to answer some questions. Now what you're going to notice is you're going to have, since it's perpendicular, you have an angle and an angle. Those are congruent. You have, since point E is going to be the midpoint, right, because it's a bisector, so it's got to be a midpoint. So this side has to be congruent to this side, and then the third side is going to be congruent to itself. Now, it really doesn't matter where you place C. You place C anywhere, and you're going to end up with side, angle, side, side, angle, side. So no matter where you place C on that perpendicular bisector, you're still going to, the triangle is still going to hold true as congruent triangles. And since the triangles are congruent, then these hypotenuse on each side are going to be congruent to each other. Therefore, any point on C, any place you place C is going to be congruent from A and from B. Any point on the perpendicular bisector. You can use the exact same logic, and you're supposed to, for point D. Wherever you place it, doesn't matter where you place it, it's going to end up being congruent from both sides because you have side, angle, and side. Okay, so that's basically what your work is all about as you go through here. And it says use triangle congruence theorem. Make sure you statement and reason. I've kind of walked through that with you. You can use side, angle, side. It says how many other points. You could use as many points as you want. Explain how rigid motion could be used to prove the points are equidistant. Well, you could reflect it over the perpendicular bisector, and it should map onto itself. So it says why isn't angle on the congruence theorems? So I would draw a triangle and then draw an identical a similar triangle with congruent angles but different lengths, and that would be a good counterexample there. Also, why is side angle not on it? So again, I would draw a circle, right? And I would put side, let's see, side length AC, right? So point C is a point on the circle, okay? And then you have segment AB, that's a fixed length. Then I would draw angle B coming back and going through the circle, touching the circle at two different points. And that would prove that I could draw point C, which is fixed distance from A, here or there, two different places. Therefore, I am not constructing a single triangle. I could construct two different triangles, even though AC is fixed and AB is fixed, and even though angle B is fixed. You would still have two different triangles. So now here you go. You're going to just go through answering the question. If you know this information, is it enough to determine whether or not they're congruent? And I'll give you a clue. Most of them are yes, and maybe one or two are no. So you just work through that and figure it out. And this is really nice. You just don't actually have to even really prove these. You just have to figure out what would be needed in order to prove the triangles are congruent. What is the missing piece of information? And that's what you have to put in there. Finally, it says 3 possible sets of congruent triangles by writing triangle congruency statements. So keep in mind I have triangle SNZ up here. I have triangle BYS over here, and I have triangle BAS over here. I've got shared angles, I've got shared sides, we've got vertical angles, a lot to work with there. So you should be able to come up with those and find the ones that have common sides and angles and verticals, and answer the rest of these questions. I think it's pretty straightforward. Let me know if you have any questions.